start a new term, new concept. Anyone hear about repetition in programming in general?
Yeah.
What is this?
I know the dry rule. The dry rule is don't repeat yourself.
Yes, repetition is repetition. So what is that? Repeat yourself, like this, or repeat something.
Loops.
Loops. Exactly. Loops. This is in programming. But today, what is the terms here? Repetition with functions, not with loops. So, yeah.
Maybe function calls himself.
Exactly. So, yeah, in programming in general, repetition with function have another name. If you want to search, for example, in Google, you want to search about what? Recursion. So what does recursion mean?
Repetition calls himself.
Yeah, the function call itself. For example, you have function and you want to use the function inside itself. That is what the recursion means, or repetition with function.
The same function?
Yeah, the same function.
The function, I think self-invoke, you mean?
Exactly. Inside the function, like for example, my name is Sahar, I call myself Sahar.
Oh.
The same thing. So, let's start. Do you remember this function?
Yes.
We do the square, cube, and what else?
A circle.
Can you moderate the...
No, it's
Yes.
clear. Okay. So we do the square. How we do the square? When I pass some number, I just what? Exactly. The cube. 3 times. And what about the power one?
It's the same number.
Exactly. Just return the same number. It is the power one. So, if for example, what you notice here,
And the same thing.
all the function the same thing, right? For example, if I want the power of 4, what I can do? I want to make another function, right? And I call it what? Power 4.
And for...
Is this good practice in programming? Yeah, it is bad practice because what?
It's repetition.
Repetition, and I have a lot of code the same time. I do the same thing, but yeah, add one more base, right? So every time I just do one step different. What is it? Exactly. So here just you can go back to the slides and read every single notes here. So you can maybe with your bear, so maybe you can review the slides. But here in the lecture, I just give the basic. With your bear, you should discuss more details if you want, okay? So, what I can do now, if I think of someone, of something, how can I refactor my code to have maybe use of the other's code? Because you know, for example, the power 4, it is like power 3, right? But multiplied by extra base. What about the power 3? It is like power 2, but multiplied by base. And what about the power 1?
It's the base.
Yeah, it's power 1, right? Multiplied by another base. How can I use all these functions inside together? I can use that?
Yes. You call the function.
Yeah.
Inside the other function.
Yeah, exactly. Let's refactor that. Look here. Add power 4. Start from here. The last one. Power 4. I said I can use power 3 inside power 4, but just the difference multiplied by base. Look here. What is the power 3 base give me? What is the result? 3 times multiplied by base. So it is the same thing that I write before, but it what? In another shape, right? What is about the power 3? How can I use
Power 2.
power 2 multiplied by base? Exactly. And what about the power 2? So here we just discover the relations so we can come up with the recursion thing. Okay? Everything is clear here?
Yes.
Now we solve the problem, but we notice we have also repetition code, right? Exactly. So, can I just have one function write everything. In the programming, always I should come up with one function, not multiple functions. So here I do everything. I should come up with some relation to come up with the base function. So here it's give me so what? Power 0. So also write power 1 in the same way. So the power 1 it is what? Base power 0. What is the power 0 base? 1. So it is like what?
Power 0.
The same thing.
I did not understand.
Here it just come up with this thing to write power 1 in the same way I write power 2, power 3, power 4. It just come up with this one to give you some idea. Later on I wanna come up with it. Because the recursion, it is what? Called the function, the same function inside the function. But I need base case. What does this mean? To stop this one, right? That is what. That is why I need the first one.
Power 0.
Yeah. This is just to come up with the recursion thing, to know what is the recursion is. But when we just start building this stuff, you wanna maybe have clear picture about the recursion. Okay?
Maybe we need to add a parameter that represents the number of the power 1, 2.
Yeah,
So
exactly.
two parameters, one base, one for
One base
for the multiplication.
So here, if I need to just make one power function, what I need? What is the exponent in general? It is what? When I have 2 power 4, for example, right?
Base.
This is the base, and what is this one? The power or exponent, right? So I need what? 2 parameters. So my power function should have what? Base and exponent. How can I write my function but without the last way? Base multiplied by base multiplied by base. Yeah. Yeah, I can mathematical power, but here today we wanna just forget about everything. We don't want to use any tools. We wanna use the same function. Yeah.
Not exactly, but we could call the function as time as exponent number.
Yeah. If we will return back here, maybe we can discover something here. Relations. What is the relation here? It is every time it is come up with the base multiplied with what?
The base
With base.
Times the time. Or times
For
the time.
example, the last one, power 4. What is it? It is base.
Multiplies the base of the third power.
So why I do everything here? Just to come up with relation and then convert it to code. So the last one, power 4, it is base, and what is power 3 multiplied by base? It is 3 bases. So it is like base and minus 1, right? Now how can I make my function to make use of this one? Clear, guys? Recursion, because it's new term, maybe it will be difficult for you for the first time. But by practice, you want to use to it. Even sometimes you don't need for loop. You just use recursion. And sometimes you want to use for loop and recursion.
So
I guess after.
we need a condition to start. That's
Yeah.
fine.
Now, the recursion function. If I want to make use of my function, always or recursion function in general, it should have 2 conditions. What is the first condition?
Stop.
Because I need to use to my function, I have base case. What is the base case?
Exponent 0.
The base case, it is the case that what? Stop my function to call itself. Because if I didn't have the stop condition, it will call itself forever. And you want to notice a lot in the exercise, error in the console. If you forget the base case, you exceed the call stack. So if you see this error, and sometimes the Google Chrome crashed, you enter for loop or infinite loop. Because you just called the function for you. So this is important, the base It is my function that I should what?
Return.
The recursive case. It is how can I call my function again to what? Come up with the result that I want. Okay? It's like here. How can, for example, I make this relation but by using the same function? Clear? Okay. So what is the best case? If the exponent equals 0, what will happen?
1.
It will return 1. This is the best case. If the exponent coming 0 like here, it should stop my condition. So this is the best case. What is the recursive case?
Call the function.
Call the function. How can I convert this equation?
I can say,
Yeah.
I think if you, the power multiplied by base,
Yeah.
we can, we got n minus 2,
Mhm.
okay, to n power of 0.
Exactly. So, just what is the base here?
Base.
Base. So retain
Base.
base. This one. How can I make use of this thing by using the power itself? Base and minus 1. Let's use, for example, base. It is the same. Multiply. I just convert the equation to make use of the same function.
Power base.
It is power. It should take what?
n minus 1,
To just come up with this result. Base and what is the exponent?
n minus 2.
Exponent
Exponent minus one.
and minus 1. And what is the base? Clear? Let's come up with this thing. Okay. Here we just ask you to just take a look for all these functions and come up with relations. It is the same relation that we talk about. No?
Okay, but excuse me. This is the result. It's the power of 3. Okay.
Here. Yeah, it is the power of 3. Or in general.
We need the power of 1. When I want to get four base multiplied by each
Yeah.
other, I need power 4 and power 3 and power 2 and power 1.
Is this work with everything? Let's, for example, try power 4. Is this work?
You can try to let us know. Yeah, that's good.
Okay. Let's try it by write it.
Just me.
Sorry, where is my supply? Oh, I should have
It's the first one. The first one on the left, the top.
the first one.
Yeah,
Yeah.
this one.
What is my function?
It's
Here.
four.
This function bar.
Take space and this one.
It's a base.
Comma exponent.
Okay. Space. Is there any space here? No. Just for the style. Okay. What is the base case?
This case is
Just you can memorize this. The recursion function should have
okay.
two things.
This case.
Base case, recursive case. What is the recursion case or recursive case? It is when I call the function itself. So what is the best case?
So
How can I make my function just stop?
If
exponent equals 0.
If base.
if n minus 1
Is
equals
it
0.
exponent or base? Is the base is fixed? What is the thing that is changeable? The exponent. So the best case, it is always also work with what? With the changeable thing. I can work with something that's changeable, but about the base, it's constant, right? So exponent,
Equals 0. Return 0.
if it's equals 0, I should return 1. Okay. Otherwise, yes.
I can't understand how could it stop that.
I want to show you. We just now now, after we write this stuff, we're just thinking about how, if I was the power function, how can I execute myself? Okay. Then retain. I come up with this one, then I convert it.
Sorry.
Yeah.
Isn't that supposed to return the base?
If it's
Zero?
just,
If
yeah.
If the exponent 0, it's supposed to return the base, not 1.
No, it's supposed to return 1.
Any base.
Multiply with 1. Exponent 0, return 1.
Okay, if you're gonna multiply it by the base himself 1, multiply by the base. You're
Here,
gonna have the
it
base.
is power, base.
Okay, anything to the power 0, we have 1. Multiply it by the base, we have the base.
Multiply with 1. But if you start with 0 from the beginning, it's only 1. There is no variation.
Okay, just carry on, guys. Let's just write the function. Then after we write the function, we want to see how this power function executes itself. Then maybe you want to comment. Even the recursion is hard. If you just practice it, you want to use to it. Because most of us use to the for loop things and this stuff, right? Retain what?
Base.
We just have this one, base, it is constant.
Times the function multiplied by
It
function.
is power, right?
Yes.
The power take one, base,
Time.
Exponent. Minus 1.
we just convert the logic to function. Now, here. Or it should take, for example, it's 2, it should give me what? Or 4, and it's 3, 8. Okay. I want to show you if you didn't with this stuff. But the error, if you see this error, yes,
Can you keep it and put like the base equals 0 and the exponent equals
the base
anything?
equals 0.
Yeah, and the exponent equals 5.
What?
I think the base equals 0, all the, it's return
Why?
0.
You mean
Yeah,
this
it's supposed to return 0, not 1.
return 0?
Just try base equals 0 and the exponent equal 1.
Here you mean? In the
Yeah,
console?
that's
Yeah.
comment. On comment.
Yeah.
On comment.
So-
Oh yeah, it didn't say it. It didn't say it.
okay, I didn't say. So power
0.
0.
0.
Yeah.
And the base is it's not like 0, anything else.
1.
It's 0.
Okay, if it's 0, if it's
Usually you will get
1.
It's your 0.
The answer.
Yeah.
Because
Because
0,
0
0 power anything is 0.
It's 0.
So
in the
0
math.
multiplied by 1, it's 0, not 1.
It's 0. The power of 0, what is it? The power of 0 of anything.
1.
What?
No,
Oh, sorry.
0.
You mean if I, for example, I have 2 power of 0, what?
Anything.
Anything.
0 power anything.
0 power anything is
But
0.
0 power anything is 0.
Except 0, I think.
0 over 0 is supposed to give you 0.
Any number in the world, for example, of 0 should give me what?
I know that.
1.
But when we have the base 0,
When I have the base 0.
how it's possible to give 1?
It's supposed to be 0.
You mean here?
No,
You mean
no,
0 power
0 or
0.
0. It's supposed to give you 0. 0 multiplied by anything is 0.
You mean 0 power of 0?
math fact. 0
No, 0 multiplied by like the base part of 0. The base part of 0 is going to be 1. Multiplied by 0, it's going to give you 0.
So your
It's supposed to
problem,
give you 0.
so your problem in 0, right?
Yep.
Okay. In the math, anyone have the math thing for the 0, power of 0?
Yeah, it's 1. Everyone knows.
Yeah. And what is it?
It's
And-
multiplied by 0. It's the base 0.
let's execute the power function, how it's for.
Can I show it to you on board?
Yeah. So,
Okay, our equation, this is our equation, right?
yeah.
If we have here 0, multiplied by anything, it's going to give you 0, not 1. This is the main
No.
equation. Why
No.
should we return 1?
We want to put another
Because when I execute anything with 1, you mean 0 by 1, it will give you 0. This is the thing, it will give you always, when it is just stop the function, it will give you 1.
Okay. Can you listen to me?
Yeah.
There's something missing. There's something missing. If we want to correct it, just can
Yeah.
yes, we can go here. And this how to comment it. Okay. Or yes, or where's or? Oh no, it doesn't matter.
Make your, let's make your function and see.
Or
Where is it?
exponent base equal zero.
Base, you mean if the base equals 0?
Yeah.
Okay.
Yeah.
If the exponent is 0, it's gonna be true.
So and it's supposed to return like the base thing.
Returns the base.
What I should pass for the borrow function?
It's supposed to return 0. If the base is 0, it's supposed to return 0, not 1. Just in math.
If the
I'm not
base
talking
is
about
0,
if the base is 0, we have 0 multiplied by anything, it's 0.
Yes,
Not one.
let's understand the concept.
called
Not with the
Yes,
math.
yes, we
So,
regard this.
I'm not
can we
sure about
proceed
the line.
with
Is
Why
0
so-
above
Because this is
anything?
wrong.
Is it 0, guys?
0 power anything is 0, yeah. But
If it
math.
is this stuff, if it is math, you just make the edge case thing.
Miss Selma, can you understand the concept?
Who said that?
Can you understand the concept? And then
Yeah,
discuss the
and
math?
we retain the math. The math is just the edge case, you can just.
Yeah, you can
No,
put
it is new for me, so you are good with the math. It is the first time for me on.
He's checking the edge cases, that's what he's done.
Yeah. So, where we done here? Let's imagine how we can execute the borrow function.
Okay.
How it is for. Oh my god. We should have a new one.
You want one?
No, I guess this is here. It is just hard to erase it.
Okay.
Let's look if the slide have it. The power function. For example, for power 2 and 4, how this will work? 2 and 4.
2 is the base.
2
and
is the
4
base, right? 2 and 4. How it will work?
So 2.
If the first one, the best case is work in the first time, if exponent equals 0, retain 1. If it's correct? No, because the exponent not 0 in this case. So it will go to what?
To the function.
To the other case, the recursive case, right? So
It's gonna return the base times.
it will what? 2
Multiply
multiplied by what?
power
Power
2
2.
and 3.
Exponent minus 1, what is it? 3.
And then it's gonna
What does this mean?
It's gonna
Retain something having the function again. It will what?
go to the function.
Call it again. So it will be 2 multiply. Power 2, 3.
Two.
What is it? It will go to the function again.
2 again.
Is exponent equal 0? No. It will ignore it. Retain what?
2.
2.
2, another 2, right?
Yes.
Power 2, 1. 2, 2, 2, 2.
2
Then
multiplied by power
2, 2.
2 and 2, right?
Yes.
Then it will come here, retain this power. So the retain will see the calling again. It will what? Call the function again. So it's 2 multiplied by 2.
And the base again is 2.
2 the base.
And then the power is 2.
This is the execution for this one. 2 multiplied by what?
Power
Exponent,
power.
2.
power,
2, 1.
2, 1.
2, 1.
And then again.
So
It will execute it. Is the base, is exponent equal 0? No. It will execute it again. 2 multiplied
2
by 2
multiply 2
by 2
again,
multiply 2
multiplied by power
no,
2,
0.
0. It will call it again. Is the exponent equal 0?
Yes.
Yes, so it is 2 multiplied by 2, by 2, by 2, by 1.
There's an extra 2 though.
No, there is no extra 2. This is the power of 0, it is 1. So let's just here. So here, first thing, it is 2 multiplied by what? Power 2 multiplied by 3. Then
2 times 2,
2, 2, then
2, 1,
2, 1. And when the function exists,
2, 0.
then what is the power 2?
1.
Should give me 1.
Yeah.
So it stopped the function at the beginning and
Can we make an example instead of math, something else? I got lost in this.
Well, it's all based on math. If you're lost in math, that's a big flag.
Yes, I was
I
able
just
to
given
find
the
this chart.
exercise, most of it factorial, summation. And what is the other exercise? Most of it math, right?
It's all math. I'm sorry for you.
Maybe the string is there or something?
Yes, string.
I guess it
Recursion
is in
of
the
string.
exercise.
recursion of strings.
There's factorial and there's this stuff. But you get the idea here, you want to discover this stuff with your brain. Okay, the idea. Let's just give you keywords about the recursion function. When I can use this stuff, when I want to do something multiple times, right?
And you don't
And the recursion function should have what?
stop.
Two parts. The stop condition, the base case, that is make my function stop, and the other part what?
The recursion.
They make use of the function itself.
Yeah.
Okay? So, first thing, you just come up with these two base cases, then make some relation to just make use of the same function.
Yeah, that's the hard
Okay.
part.
Yes, the hard part is just what?
Finding the relationship.
Find the changeable thing. What is the changeable thing here? The exponent. Here, everything is constant, instead what? Exponent. So, everything is constant, just I want to search about the thing that I want to change, then put it. And then search about how can I stop my function. What is your name? Sure. Okay. When you will be with your bear, I want to check on you
Please.
during the day. Okay? Any question, guys? You can ask us a lot of questions when you just make the brainstorming with your bear.
Yeah.
But you get the basic idea because the lecture will give you the basic idea, not how you solve the exercise. Here? Yes, please.
The first function was just saying about if with the condition if exponent strictly equals 0, it will return 1.
Yeah, you meant if the base equals 0?
Yes.
And just add another if function.
Yeah, you just
If
like,
condition.
Add an exception.
Yes, I know, but I
Yeah.
have a question there. And else return base multiplied by power of base equal by exponent minus 1.
yeah,
So if in the first condition of f exponent strictly equals 0, if we return base, the mathematical condition will be correct.
if I return, yeah.
Yes. So
Let's
that's
make
what
it.
Yusuf was saying. So the function
No,
will be
if you
correct.
return
Let's see what will happen. If, for example, is the base changeable?
No.
So,
It's gonna
let's
multiply by
let's
the
see what if I just return the base here.
If you return base, you will be with the power plus 1.
Yeah. Here, when I make the recursive condition, I want to search about the changeable thing. Is the base changeable part? No. I won't play with it. Even I don't want to use it or retain it because it is here in this case. What is it? 2, right? I mean here in the slide. It is 2. So it will multiply it by 2. And let's try it. Maybe I know. If I just make it base and save it,
It's gonna be 16 instead of 8.
You will run
because
extra.
I want to play just with the exponent.
One more extra.
Okay, let's make it 2,
0.
4,
That's it. One more.
2.
It's
And multiply by it by extra base.
Yeah. Exponent minus 2.
Exponent minus 2. Yeah, but is it working?
Can you try that?
Other
Zero,
stuff?
zero,
No,
please?
but that's just for the 2.
Yeah, but for the other stuff,
I think, can you go to the subtext, please?
Oh.
Can you try the 0, 0,
For-
please?
0, 0.